that we are here from Salt Lake City, or at least Mary is. Broadcasting Live is my podcast from here, from Salt Lake City, the very exciting KubeCon 2024, North America. And here I'm joined by Manny Sarkar, my co host of this Elusive AI podcast. So, Manny, how are you doing?
I'm good. How are you?
I'm good, thank you. So exciting, First of all, to hear, in KubeCon, as you can see, right? I can try to because it's my laptop. My I can really quickly too, as you can see that there's a donut table, but donuts almost all gone. They're serving donuts in the afternoon, and then people are discussing things, and you can see too. All the big vendors are here: Microsoft, Google Cloud, and AWS, and in fact, this is what we're going to be talking about. These cloud providers, right? They are also like, providing all of the services, Kubernetes as such, KubeCon. How does it, support AI workloads? And that's the
Mhm.
thing Manny and I talk about. We thought it would be great to do this episode directly at KubeCon, Center of
Yeah,
Action, as well as the fact that these how actually Kubernetes services itself can be enhanced by using AI assisted technology too. So yeah, so
mhm.
very exciting. Yes, and kind of today's episode more about this kind of infrastructural, workloads and all of these things too, that they are necessary to keep our large language models and small language models running so that we can use them for our Gen AI applications. So and
Correct.
many.
Yeah,
Yeah, very so good to see you. So yeah, yeah, wonderful.
yeah.
Yeah,
So, I mean, where do we start? I mean, Kubernetes is a huge monster, isn't it? And hence
exactly.
there are lots of services that are wrapping
That's
Kubernetes
right.
to make it easy to manage and work with
That's right.
Kubernetes, isn't it? So,
That's right.
it comes there comes a time that you can't do a lot of the things manually or hard code
Sure.
it or write every small thing for a small thing to happen, isn't it? um,
Sure.
you need to make use of intelligence as well that is gathered from behaviors
That's
of
right.
the different aspects of the application, and then maybe
That's right.
trigger those aspects when as and when needed, and not have to look for it every time. So
That's
basically
right.
that's making the work flow just like an intelligent human would do, right? um
Exactly.
actually I would say that, if you know, in
Yeah.
the early 60s 50s 60s 70s, even early 80s, and only in the 90s did
All done.
AI and
Yeah.
machine learning become practical. But
Yeah.
before that it was all theory, all the way
That's
from
right.
50s to early to mid 80s and late 80s. It was all theory. It was
Terry.
only with the yeah it was only theory. Only with the advent of machines that
Yeah.
could scale and process large amounts in small periods of time real quickly, without taking a lot of resources,
Yeah.
which were not available in the early 50s 60s 70s
That's
80s. Only
yeah.
then was machine learning a reality. till
That's
then
right.
till then it was theory. And so
Yeah.
Kubernetes is this automation machine, this beast that has
That's
definitely
right.
played a role in this
Yeah.
automation process somewhere down the line,
That's
that has made it
yeah.
possible and enable
That's
machine
right.
learning processes,
Yeah. Totally.
right?
Totally. Yeah.
So
Yeah. That's
you
right.
could say it has always been assisting AI processes, or AI like
Yeah.
processes,
It's
or automation,
yeah.
or other forms of AI
Yeah.
in the past till date, and it will continue to
Totally.
do that in coming time as well.
Yeah, that's right. So yeah, and I know many, you and I, even I'm curious too. I mean, in general, right? If we are application developers, we're going to develop Gen AI applications, and sometimes our focus into developing using the API. We are kind of many levels above the infrastructural side of things. But
Yeah,
exactly how does it work, right? Obviously, I mean, Kubernetes play a significant role in terms of first, training in the LLMs training, large language models, small language models training them. They need machines to run these workloads and,
yeah,
the training part and then of course inferencing as well. So how does it work? It's not really documented. I think unless you work for a company like OpenAI, work for Anthropic, training Claude, all these things, then you know how this whole procedure goes. It is still kind of doing things like continuous integration and continuous deployment for all the testing and your code and everything. When it's got changes, it's gonna be built. Building all these the language runtime essentially is the language models. But how does Kubernetes like orchestration, maybe in a high level, right? What is your understanding? How does it help, right? And all these things
So
that are going in. Yeah,
so building a model. I mean, we were covering in the previous episode, right?
that's
That
right.
the large language model building process, and I'm only glossing over the surface. I do not know the minute exact details, because none of the model makers are documenting this and publishing this, because it's their trade secret, right? It's their secret sauce on how they're building their
Sure.
model. They
That's
wouldn't
right.
publish it. We know
That's
roughly
right.
from high level that they are
Yeah,
using
that's right.
reinforcement learning assisted by human feedback. They're using natural language
That's
processing
right.
for sure. They're using some machine learning techniques. They're wrapping all of these with APIs, so that
Yeah,
when we call them and give them the right
that's right.
request objects, they come back with the right response object. They are using caching here, there,
That's
and
right.
everywhere, so that they don't reinvent the wheel each time. And
Exactly.
if it's a similarly looking response, they
That's right.
and it's controversial. Are they caching it, or they're making the model
Yeah.
regenerate every time? Different
Yeah.
people are doing different things,
Yeah.
right? I think
That's right.
I think from observation,
Yeah.
it looks like Anthropic might be caching your requests, so they don't repeatedly make
Yeah.
the model give you the same answer. But others might be doing other things,
Okay.
right? So this
Yeah.
large language model business is a machinery of its own. For example, and I was just thinking of this when you
Yeah.
said that, if you look at KubeCon as a conference,
Yeah.
there are so many activities going on, right? And it's
Exactly.
coordinated by so
Exactly.
many different people at so many different levels, right? You have the
Exactly.
organizer,
That's right.
sub-organizer, then you'll have people who are
Yeah.
owning the
And then
booth, people are managing
that's right.
the food,
Yeah.
the list goes on, right?
Yeah.
So, and then
Exactly.
there's probably one person or a few people propagating all these instructions to the rest of the lot. And then you have
Yeah.
also the people from companies coming in, the attendees coming in. They have their own hierarchy as well, right? Of who gives order to.
Sure. Yeah.
For example,
That's right.
you represent your company here, so
Yeah.
your company is kind of influencing you to be here, right? You're representing.
That's right.
So
That's true.
this whole KubeCon ecosystem can
Yeah.
be a replica of what a large language model ecosystem could be. Lots of
True. That's
centralized
true.
and decentralized
Sure.
hierarchical pods
Yeah.
or
That's
networks or
true.
orchestration setups
Yeah. Yeah.
that
Totally.
are working independently, yet they are in the same ecosystem. And towards the end,
True.
they're producing value or results
Yeah.
and output to
True.
one thing,
Yeah. That's
right?
right.
So
Yeah.
there might be a lot of
Yeah.
databases, a lot of
Yeah.
file sharding happening, a lot of replications happening. Um,
That's right.
and basically, if you look at the model, large language model uh, as one entity, there has to be a start and a finish, right? Start is
Yeah.
where all the raw data comes in the middle all
That's
the
right.
processing happens, in the finish part is where the model
That's
is
right.
finally built and wrapped around
That's right.
by um, an
True.
API or
Yeah.
something.
True.
So
Something.
if this whole thing is a machinery,
Yeah.
there are different parts of it that need scaling,
Yeah. True.
and then those parts need to talk to each other as well. But
Yeah.
the parts that need scaling and
Yeah.
orchestration and
Yeah.
decentralized management,
Hmm.
Kubernetes could be one of the chosen technologies to orchestrate it. Or they could use another technology that under the hood uses Kubernetes,
Yeah. True.
or you could
Totally.
hold another technology that only uses Docker containers and it
Totally.
does its own orchestration. So there's
That's
so
right.
much, yeah.
There.
But
There.
the KubeCon is not just supporting Kubernetes technologies. I'm sure it's
Oh yeah.
open to non-Kubernetes technologies that also do orchestration.
Yeah. Yeah. Totally.
So
Absolutely.
such setups could be also present in the
Yeah.
large language model factories. you're going to
Oh
call
yeah,
them.
yeah, true. Well, yeah, it is very true. You
So
actually now, yeah.
do you get a picture of what a large language model setup could look like? Clusters and clusters of computers, all
Oh
of them,
yeah,
each
yeah,
of them grouped together,
yeah.
independently
Yeah,
doing their own stuff, but also some others that are coming in and
that's true.
gathering the knowledge and information from the swarm and post putting it somewhere else. And eventually, you have a final thing that's built that you and I
Yeah,
use called large language
yeah,
model.
yeah. True, 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 true.
So
Yeah,
the
yeah,
orchestration has to be done by something Kubernetes like,
yeah,
for example.
yeah, yeah. That's right. Yeah, yeah, yeah. It is.
You had
It
a
is.
question.
I mean,
You had a
yeah.
question
My
earlier on.
question, even I'm thinking, right, or actually even now, it makes me think, right now. There, don't mean to digress, but also I'm experimenting, right. Now it also turns to the other side, in which Kubernetes too. It's all the services it is using. Some of the services can actually be leveraging on AI technology, right? AI assisted technology. Maybe Kubernetes need to do some things, and as you said, right, some of the functions is like in a large KubeCon. Yeah, you got, like you said, even the food service, even some things that are you're running the shows, running all these things, and some things might be tedious. You could actually be using an AI assisted bot to do some of the things. While it's kind of interesting, in which Kubernetes helping the workloads, but the AI itself, the inferencing part, you can use that to implement your Kubernetes too, and kind of helping each other out.
Yeah,
Essentially, that's what I'm thinking.
spot on. As of documentation is concerned, no, none of that
That's
says
right.
any
Yeah,
aspects of Kubernetes is using AI to enhance
that's
its
right.
capabilities.
Yeah,
But there are services that use Kubernetes, have
yeah,
wrapped AI around their own services.
that's
So,
right. Yeah,
and there are some names that we can think of, like Spotinst. Okay, the plat
yeah,
it uses
that's
AI
right.
to optimize the cluster scaling and workload
That's right.
placement in Kubernetes
Yeah,
environment. So basically,
yeah,
something before it goes to the orchestration, or they've built something around the Kubernetes orchestration that
yeah,
helps them figure out how to do the
yeah,
scaling and optimization
yeah,
in a
yeah.
more
That's right.
optimized, in a more scientific and efficient way, right?
Yeah,
So
true.
that's a great example.
Yeah.
There's also Dynatrace that uses
Oh,
it
yeah.
for observability and automation. There's
Sure.
Turbonomic, also doing the
Yeah.
same thing, optimizes application
That's
resource
right.
management in Kubernetes
That's
clusters.
right.
The Rancher
Yeah.
is using
Yeah. Rancher.
AI
Yeah. Yeah.
to assist
That's
the
right.
features of monitoring and optimization. So yeah,
Yeah.
they there's a whole lot of them. So basically, what they are focusing on is predictive scaling, meaning
Yeah.
if
That's
you
right.
follow the word predictive scaling means, um,
Scaling. Yeah. Yeah.
it's to scale in
Yeah.
advance, to know in advance that you need to scale,
Yeah.
not to
That's right.
scale when you're asked to scale, not to scale
Oh,
when
yeah.
you just
That's right.
notice, oh, I'm
And the
running out of
loads. Yeah.
clusters, I'm running out of servers, I need them
Yeah.
now.
I
No,
need that now. Yeah.
before
Yeah.
you
No.
run out of them, you start scaling. This is what some of
Scale.
the
Yeah.
Amazon services do. I can't
Yeah.
remember. There
True.
was something that that scales a few ahead, a few
The-
clusters ahead, a few
Okay.
extra pods before it's going to run out of them.
Oh. Oh, okay, okay.
Yeah,
Yeah, so it's essentially this mechanism that's kind of self-adjusting,
correct,
so to speak, right?
correct, correct.
It's sort of
But
self-adjusting. Yeah,
not
okay.
on the spare of the moment, before the spare of the moment
Yeah,
happens, right?
yeah, yeah,
So
that's right.
that's
Yeah, yeah,
then
yeah. So,
detecting anomaly detection. Now, anomaly detection is such a broad word in the orchestration world, right?
sure,
Um,
that's
and
right.
I
Yeah,
think that needs more context. But resource optimization as well, right? Like
yeah,
some clusters might have too many pods in them, and they're
that's
not
true.
all used, and there are some that are lacking them. So proper resource management will
Yeah,
have just about enough pods in all of them,
yeah,
and that's also where
that's right.
auto what is it, scale predictive scaling comes into play, right? Because
Yeah,
they go hand in hand, isn't it? Because if you have less in one place and you
Yeah.
have too much in the other place, that's not optimized resource management. But also it means that if you have less in
True.
one place,
Yes.
predictive scaling will tell you, oh, I need more.
Yeah.
So then you go and
That's
create
right. Yeah.
extra. But then what
That's
about the places where you've created extra? You're unnecessarily wasting that resource, right? Why not destroy
that's true.
80% of
Yeah.
them or 90% of them that you don't need?
Yeah. Yeah.
Isn't it?
That's right.
Isn't it?
Yeah. True.
And then you
That's
have
true.
performance forecasting.
That's right. Yeah.
Like how
Performance
performance forecasting.
forecasting. Yes. Yeah. Yeah. True. True. Yeah.
So what about performance forecasting? There's a couple of things here, right?
That's
One is
true. Yeah.
um, that it says you know the behavior at certain time,
Hmm.
the you need to, you will see a drop in performance,
That's right. Yeah.
right, or a rise in performance,
That's right.
right?
Yeah.
So
That's right.
if you
That's
see a
right.
drop in performance, that means you need to, you already know that
Yeah.
that time segment, right, because of
That's right.
past
Yeah.
behavioral patterns. Then you go and
That's right.
provision resources
Yeah.
so
The
that there is no
provision. Yeah.
drop in. So that's how you forecast
Yeah.
performance. Like you say, okay,
That's
it's
right.
performance high now. How long will it stay high? In time
That's
t,
right.
will it still stay the same? Oh no,
Yeah.
historically it's noticed in time t does it drop. Okay, in time t, I'm going to provision some
Yeah.
extra resources or extra clusters.
Yeah. That's right. Yeah. Yeah. True. True.
They
True.
they
Yeah.
all they all are kind of feeding into each other.
Yeah. Totally. Totally. Yeah. Yeah. Yeah.
And
So.
I'm not an expert in this field by any stretch. Especially the
Yeah.
observability and monitoring is very broad
Yeah.
and deep and needs a lot of expertise. But
Oh.
some of
Totally.
these things are very much, what's the right word to use here? Um, the bread and butter of, um,
Oh
or
yeah.
the minimum necessary that monitoring and observability should be used for.
Should be using. Yeah. 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 Totally. Totally.
Yeah.
Yeah. Yeah.
So you
I
can
mean.
see already. So you can see already
Yeah.
now there are algorithms that have been written in,
That's
like
right.
how the elections happen in the Kubernetes
Oh
world, right?
yeah. Yeah. That's right. Yeah.
And there
Yeah.
are some other ones I forget them. See, it's been a while since I've been looking into that area,
Sure.
and there are
Sure. Yeah.
algorithms written for that. But a
Yeah.
lot of them are very heuristic in nature and are only mathematical.
Yeah.
Whereas
That's right. Yeah.
whereas in today's time, you need them to be intelligent in the sense
Yeah.
that
That's
it
right.
needs to
Yeah.
sense the need for it and way before the need for it,
Yeah.
and then
Hmm.
appear, and then when it's not needed
Yeah.
anymore, and way before it's not needed anymore, it should disappear,
True. Yeah.
right?
Yeah.
So
Totally.
that is
Totally.
where AI comes in,
Yeah. Totally.
because use observe will
Yeah.
observe patterns, will observe
Observability.
time,
Yeah.
will try to
That's
match the
right.
two together, and
That's
then
right.
based on
Yeah.
nuances and
To,
anomalies, it'll create new
that's
behaviors.
right. Yeah, totally. Now, also, then my question is that generative AI is dealing with more for generative purpose, leveraging on NLP language, human languages, input output. But how about like the traditional? We talk about the discriminative AI, right? Like before this Gen AI era. But we can actually be leveraging on predictive AI to do
Oh
some
yes,
of these
yeah, yeah,
kind
yeah.
of
All of
yeah,
these things
right.
we're talking about, they don't have to be
Yeah,
generative AI at all.
that's right. Yeah, in
All of
fact,
these can
yeah.
be done with discriminative narrow AI.
Discriminate area. That's right. Yeah, exactly.
Yeah,
Because that already we saw systems already doing that before the
correct,
Gen AI
correct,
time.
correct.
Yeah, yeah.
I
That's
don't
right.
see.
Yeah,
I think for generative AI, this may be a little bit of a overkill because it
yeah.
might be a bit
Exactly. That's
expensive.
what I'm thinking.
Generative AI is very
Yeah,
good at unstructured
yeah.
analysis
That's
of
right. Yeah,
unstructured and
yeah.
graph-like data
That's right.
points,
Yeah, that's
whereas
right.
what we are talking about here
Active.
is a lot
Yeah,
more like time series and patterns, which
yeah,
generative AI can also handle. But it's like taking a hammer, well,
yeah.
not a hammer,
That's
but
yeah,
a
exactly. But
sledgehammer,
yeah,
taking a
that's right.
sledgehammer to crack
For
a
a
nut.
little nail. Yeah,
Yeah, oh
that's
yeah,
right.
for
Yeah,
to
true.
put a little nail in a
That's
thermocol,
right.
to push a
That's
nail in
true.
a
Yeah,
thermocol, you're going to try to use a sledgehammer,
that's right. Yeah,
right?
true, true, true.
So
Yeah, yeah,
that
that's
that may
true.
not be necessary. It's It's an overkill.
Yeah,
Um, it
totally.
would
Yeah,
produce results, but there would be
yeah, that's
delays,
right.
and it wouldn't be
That's
as
right.
fast. So there are pros and cons to it, right?
Yeah,
It would be able to
true.
give you more precise information.
Yeah,
Well, it could be asked to give you more precise information, but
yeah,
it needs
that's
to be updated regularly with
yeah,
all
that's
that is
right.
happening in the world,
Yeah, that's
world of that orchestration. I mean, and then it'll
yeah,
be able to
true.
tell you the good picture. Whereas
That's right. Yeah,
the discriminative system would be forced to maintain a map of all the stuff that's happening, and would be
okay.
faster and more efficient and more focused on doing that specific thing. Whereas an LLM is a very general tool to use it to
Yeah,
do.
true.
I mean, it can be
Yeah,
used and people might be using it, but I feel at the
yeah.
moment it's an expensive tool to use to
It's
do this.
an
Whereas our
it's surely.
discriminative narrow AI,
Yeah,
there are lots and lots of functionalities and features
yeah,
available that can be put together
yeah,
to do preventive,
yeah. And it's more,
yeah,
yeah, more
preventive, predictive
optimized.
scaling, yeah, predictive
Yeah,
scaling, resource
that's right.
optimization,
That's
automated
right.
troubleshooting, performance
That's right.
forecasting. So that's one place where Gen AI may be more useful is the
Yeah,
automated troubleshooting. That's
the
where I would use
automated.
that's where I would use
Oh
Gen
yeah,
AI.
that's yeah,
Yeah.
yeah, yeah. That's
Whereas
right.
the
Yeah,
other places, Gen AI could be used as a second opinion, like in the predictive
secondary.
scaling.
Yeah,
Yeah.
thing. Yeah,
But the primary would
totally,
be to
totally, totally.
maintain a map of resources
Yeah,
and keep a track of where the resources are
true.
rising and falling, utilization,
That's
and
right.
things like that.
Yeah,
Yeah, it
yeah,
would be
totally,
complex,
totally.
but
Yeah,
people have written algorithms to manage that well, as opposed to making Gen
that's
AI
right. Yeah,
understand it, to manage it, and produce results out of it.
yeah. Oh yeah, yeah, totally, totally.
Does that
Yeah,
make
yeah,
sense?
yeah. Yeah, I think it makes actually makes a lot of sense. And to me, I think it also is pointing to the fact that now that we understand, Gen AI's capability, its limitations, its lavish, cost of using it, and maybe we should narrow it. Essentially use the right tools for the right job. As you said,
Correct.
when we're making predictive predictions, sometimes not necessarily Gen AI is too much. It's an overkill. So therefore, yeah,
Absolutely.
I see it more like we are more moving towards Gen AI and discriminative AI, predictive AI, all coexisting. We're using the right kind of AI for the right kind of job. I think, yeah.
Yeah, yeah.
But
I
yeah,
mean,
but yeah,
through you could one could put up a
yeah.
system in place using agents like the agentic,
Yes, yeah.
yeah,
Agents,
where the
agentic, yeah,
LLM routes the
yeah.
calls to the different agents based on what's needed,
True. What
but
is
the
yeah.
actual process is done by the agents. So
By
the
the
LLM
agents,
is only
yeah, yeah, yeah,
orchestrating the routing. It's
yeah,
not doing
yeah.
the
True.
execution. The execution is done
The
by the agent,
execution, yeah.
and the
By the
agents can be
agents, yeah.
discriminative AI processes.
Oh yeah, totally. Yeah, I
Yeah,
like that idea. In fact,
yeah.
that was
That
that was that's
that
what.
is a,
Yeah,
correct. That is a better use of
yeah.
LLM than to
And
make
LLM,
LLM
yeah,
do each one of these. And of course,
yeah,
somebody will
totally.
come and prove me wrong for some of these, but
Yeah,
you get the idea, right? It's not
I
like
get
using
the
LLM
idea.
for
I
everything.
think exactly, yeah. But I really like the idea of using a agentic approach for doing things because that's the idea. As you talk about KubeCon, the conference itself as an example, you got so many different, activities going on. Each activities are involving so many people, right? People can become the agents and or whatever kind of engine to power each thing. So you have people at the booth demoing. You have people at the booth talking to customers walking up to your booth, that type of stuff. So these some of these things, how do you react is can be handled individually by agents. That's their only job, and so you make your process to be quite efficient. But of course, you need that overview of an a that overseeing. It's like a project manager overseeing,
Mm,
making sure everybody is doing the right job. Everybody is coordinated somehow, like you said, doing different things, but this very dynamic, but
yeah,
somehow there's this overall output is to put on a good show in the
yeah.
KubeCon, for
I mean, I
example.
won't be surprised to that
Yeah,
you will also not be surprised to see in
yeah,
time to come, not very far from now, people are probably already working on it, that the
yeah,
Kubernetes
totally.
orchestration system has
Yes,
been
yeah,
redesigned
yeah,
such that a lot of the routing of what call needs to be done by whom is actually
That's true.
managed by the LLM, whereas
That's
the
right.
actual execution is done by
Oh
the
yeah, the
agents
agents, the
that
agents
know how to
itself. Yeah.
that listen to
Network
the orchestrator, and then
later.
they
Yeah.
themselves go ahead and orchestrate.
Yeah.
So you have an
Totally.
orchestrator of orchestrator, which is the LLM,
Orchestrator.
and the
Yeah.
orchestration, the second level of orchestration, is what the Kubernetes
Yeah.
orchestration is about. That
Yeah.
is a
Totally.
lot more efficient because that means you don't have to write code for
Yeah.
every
That's
small
right.
thing that you need to do.
That's right.
Okay,
Yeah.
you just write
Totally.
your basic
Totally.
tooling, and the
Yeah.
LLM takes care of
Scary.
how
Yeah.
it needs to be used. Of
All
course, you'll
the
need to write a
execution.
finite number of tooling that can be in
That's right.
combination and permutation used such a
That's
way
right.
that you don't have to
Yeah.
write literally everything for everything.
Sure.
That's
Yeah.
going to go away.
True. True. True.
We'll have to
Yeah.
write very specialized solutions, lots of
Sure.
specialized solutions that the LLM is going to be able to agentically execute, orchestrate and
Yeah.
execute,
Be a good
and
person. Yeah.
exchange the and what's the right word here, augment them
Augment. Oh,
and
yes. Yeah.
compose them
Yeah.
such a way that uh, it does the job. Things even you didn't think would be possible, it has been able
Yeah.
to do it because of the
To
Lego
do
blocks
it.
that you built. That it
Yeah. Yeah.
goes and further combines them and uses them.
Oh yeah, true, true. Yeah, I get it. Yeah, yeah. I think it's exciting, and like you said, I wouldn't be surprised. Yeah, there are already systems being built in this towards this direction too. I believe. Yeah. So,
Yeah,
yeah, it will be interesting to find out. Yeah, yeah, very cool. Well, it is. I have to say too, it is getting late. I think we agreed that we'll do about a half hour.
yeah. I think we said a lot
Talk,
in
right?
the 30 minutes, and I think there could
Yes,
be
we will.
another session like this where we
Yeah,
go a deeper dive into it when we have collected enough resources,
yeah,
because there's not a lot written and spoken of in this area, because I think the Kubernetes world is a lot about DevOps and uh,
yeah.
cloud engineering and um,
That's right.
infrastructure, and there is not
Yeah.
any data science or much data science or AI.
Yes.
It's very AI drive. It's more
Yeah.
engineering and less machine and intelligence.
Yeah. The machine. Yeah, yeah. I think that's also what I'm looking at too. We're spending a lot of time dealing with infrastructural thing, but I think it's probably the same thing for any kind of newer technology that comes out. We like the whole humanity spending more money investing in the infrastructural side, but eventually too, it's really the application that adds that is able to give us true value. I mean, the
Mm.
infrastructure is there only to support what we can
Yeah,
build.
I
I
mean, it
think
is
the
necessary. It's the
creativity
framework. It's necessary. It's
is
the framework. It's
necessary.
the
Yeah,
skeleton. It's the wireframe
yeah,
on which the application sits.
yeah. That's right. Yeah, I look at it like initially when Linux came out, right? Is everybody was talking about this operating system, but now nobody talks about it because
It's
it's
gone
it's
behind in the
understood.
scene. Yeah, it's
Yeah,
obvious. It's an
exactly.
obvious
It's
thing.
all
You need to have an
understood.
operating system
Yeah,
on which
and
the
then
application will
yeah,
have to run.
exactly. So very cool. Yeah, yeah, wonderful. So yeah, so we should spend our next prepare for our next episode too to talk a bit
Yeah,
more
I
about
think
this.
it'll be
And
an
plus,
interesting
yeah,
one if we can get
yeah,
into the hoops of, has
yeah,
anybody applied AI into their
yeah,
Kubernetes
in
design
Kubernetes
of
too.
architecture of
Yeah,
things that they're working on, or
ex-
there's a service that is
exactly.
wrapping Kubernetes such that,
Then work with,
just like some of
yeah,
the services I named, and how are they
yeah,
using it, and if we can
yeah,
get our hand on some example code that actually does it, that'll be
yeah.
awesome to see.
I think that would
Quite
be
possible it might be written
really,
in Go or Ruby,
yeah,
because
go,
that's kind of,
yeah,
or Rust even.
yeah, Rust, yes, yeah,
Yeah.
Rust and Go are the things. So
So,
yeah,
so maybe it'll
yeah,
be
very cool.
interesting to have a look at Rust, Go, and machine learning, where machine
Sure,
learning
yeah,
is like, have people
yeah,
built machine learning
that's
pipelines
right.
using Rust
Yeah,
or Go.
totally. Rust
Yeah,
and Go. Yeah, yeah,
possibly
that
even
sounds great.
in
Yeah.
Ruby.
Oh yeah, that's true. And are people still using Ruby? You think? Yeah, for
Okay,
machine learning.
um, if you
Oh,
look into, I don't know if it's Ansible or Terraform, the underlying
uh,
language in which were initially written in is Ruby.
it's Ruby.
So
Okay, okay, I didn't know.
if you had to add AI features to
Yeah,
Ansible and Terraform, which one of these
yeah,
days will happen, or it's probably
that's
already
right.
happening
Yeah,
behind the scenes as we speak,
yeah,
then they will have to write in a language that Ruby can talk to, or in Ruby
yeah.
itself.
Yeah. Yeah. Okay.
Again, I
All
don't
right.
know the details of it, of how people want to solve such problems, and
Yeah.
people can become very ambitious. Sometimes they'll wrap this with that, and then they'll package into their
Yeah.
original framework, and everything works fine. There's no
True.
latency.
Yeah. 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 Yeah.
Oh, there's very little
Okay.
latency.
Yeah. 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 Yeah.
So
Okay.
that'll be something interesting to dive into. But my
Yeah.
suspicion is, but I'm still an outsider in this space. My
Ah,
suspicion is that we
you
won't
are.
find too much, but even very little, whatever little we find,
I
will
think.
be useful.
Yeah. 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 Yeah.
It's a
You
niche.
know that.
It's a niche area nobody has looked
Yeah.
into.
Yeah, British. Yeah, that's right. I like that though. Yeah, but like you said, you feel outsider. I also feel. I think we all feel we're sort of outsider because the things are happening every day. You know,
Yeah,
that like what we thought we knew today, then tomorrow will be obsolete, or we need to have new level of understanding. Is what it is.
yeah,
So,
yeah, yeah.
yeah,
But I
yeah,
mean,
yeah,
personally, I do not bask too much into the infrastructure and Kubernetes world. My work is
yeah.
a lot around backend engineering, machine
Application
learning,
engineering.
data
Yeah,
science, data engineering,
that's right.
software engineering
Yeah,
mainly.
software.
So
That's right.
yeah, and I do, well, doing all of this, you still need to know do some DevOps and
Oh,
infrastructure, which I
totally.
gladly do.
Yeah,
But I
yeah,
I am
yeah.
not day in and day out into that, like I am with
That's
the
right.
software
Yeah.
engineering components,
Well,
machine learning
yeah,
components, and all that stuff.
I guess
Yeah,
same with me. I think in my
yeah,
initial start of my career, I was more like paying attention to operating systems. That was my passionate area. But I
mm,
think with that understanding, it helps too into other
yeah, exactly.
infrastructural thing. But I don't spend nearly as much time as I used to. Yeah.
Yeah,
So
I
yeah,
understand.
yeah,
I
yeah, yeah,
understand.
yeah, yeah. Cool. Yeah, very cool, Manny. Thank
Yeah,
you
thank
so
you.
much. And so, yeah, so I think we will end the show for today. And
Yeah,
thank you very much for those who have joined us or watch it afterwards too. And
yeah,
I'm going to try to do this outro properly this time. So, yeah, so
yeah.
thank you. And thank you, thank you, thank you. Yeah, okay. All right. Yeah, let me
Thanks, Mary.
do
Thanks,
this one thing.
everyone.
Thank you. All right, then. Thanks, Manny. Yeah, okay.